Alright folks, in this video we are going to be talking about information from section 9 of unit 2 of AP Calculus, the quotient rule. We're going to take a look at how we find the derivative of a quotient of two differentiable functions in this video. So if you remember kind of where we led off with in the last video, we talked about, wouldn't it be nice if the product rule was a certain way? And of course it wasn't. And we're going to start with the same kind of idea in this one. Wouldn't it be nice if the derivative of f of x over g of x was equal to f prime of x over g prime of x? Unfortunately, it's not. So what we need to do is we need to go ahead and figure out what it actually is going to be equal to. So what is the derivative of f of x over g of x? All right, so in order to start developing our rule for the derivative of quotients, we're going to, use the same technique we've used so many times. We're going to start with the limit definition of the derivative. So we'll go ahead and start by setting this up. The derivative with respect to x of f of x over g of x is equal to the limit as h goes to 0 of, well, we put x plus h into the quotient, and we put x into the quotient, and we've got this as our numerator, and all of that over h. Okay, now probably a good first step for us here in developing this is to go ahead and clear out the numerator, the denominators of the fraction that show up here in the numerator. So what I'm going to do is I'm going to go ahead and take this expression and multiply by the two denominators that show up in our numerator here. We're going to multiply the numerator by those, and we're also going to multiply the denominator by those. So we're going to multiply numerator and denominator by the quantity g of x plus h times g of x. And what happens is that gets rid of both of our denominators that appear in the numerator to begin with. When we multiply this times the first portion, the g of x plus h, that's in the denominator here, and the g of x plus h here cancel each other out. So we're left with the numerator of that first fraction times the remaining factor g of x. And then same thing happens with the other term. The g of x cancels out with this g of x, and so we're just multiplying the f of x by the g of x plus h, and so that becomes minus f of x times the quantity g of x plus h. And we've got all of that over h times g of x plus h times g of x. Okay, so we're making some progress. Now, our next step in our plan, we're going to do exactly what we did in the product rule in the last lesson. We're going to go ahead and add 0 in our numerator. And the form that we're going to use for that 0 is we're going to, if you remember our strategy from last time, we were looking for something where we took one of the factors from each of the terms in this and had one with an F and one with a G. In this case, that's going to enable us to add in negative f of x g of x and positive f of x g of x. So there we go. We've added 0 into the numerator, and that is going to do some nice things for us down the road. Okay, so far so good. Now in this next step, we're going to actually split this into 3 different limits. We're going to split by multiplication, and when we do that, what we're going to do is we're going to bring these two pieces into a limit of their own, and then we're going to take everything else and we're going to split that into 2 limits by the sum. We're going to take these 2 terms from the numerator and group them. And we're going to take these 2 terms from the numerator and, oops, I didn't change colors, and group them. And both of those will be over this h right here. Okay, so here's what that looks like. This turns into the limit as h goes to 0 of f of x plus h g of x minus f of x g of x all over h. And I'm going to need to bracket this because this is going to be multiplied by the last quantity that we do, plus the limit as h goes to 0 of f of x g of x minus f of x g of x plus h all over h times limit as h goes to 0 of 1 over g of x plus h times g of x. Okay. Let's see, what else can we do? Okay, some factoring in these first two limits that are going to help us. We're going to, in this first one, we're going to factor out a g of x. And that leads us to this limit right here. And in the second one, we're going to factor out a negative f of x. Now you'll see in a second the reason why I factored out the negative f of x is because then it turns it into the familiar form that we've seen so many times now in the limit definition of the derivative. And so we've got that going on right now. And now, with respect to these limits, since these limits are in terms of h, that means that this factor right here and this factor right here are both constant with respect to those limits. So we can factor them out of their respective limits individually. So this turns into g of x times limit as h goes to 0 of f of x plus h minus f of x all over h. And then we factor out a minus f of x times limit as h goes to 0 of g of x plus h minus g of x all over h. And then we'll multiply that. You know what, I'm going to go ahead and take this last limit here a while. If I take the limit as h goes to 0 of this, I'm just going to substitute 0 in for h, and this turns into 1 over g of x times g of x. And now, folks, we are pretty much at our end game. If you look at what's inside the bracket here, we've got g of x, and again, you should recognize by this point in time that this right here represents the limit, represents the derivative of f. And this right here represents the derivative of g. So there we go. And that's 1 over g of x squared. There. And now I'm just going to combine that into a single expression where I take what's inside of my brackets and put it in the numerator of a fraction where the denominator is the quantity g of x quantity squared. And bada boom, bada bing, there is our quotient rule. This is the derivative of f of x over g of x. Okay, and if we go over to the next page, you'll see we write the quotient rule out there. If f and g are differentiable at x, and if g of x does not equal 0, all bets are off here if g of x is equal to 0, then f over g is differentiable at x, and the derivative of f of x over g of x is g of x times f prime of x minus f of x times g prime of x all over g of x quantity squared. This is by far the most complicated rule that we've talked about so far for finding derivatives. So looking at this, if you think this might be difficult to remember, use your resources. The internet is a treasure trove of ways to help you remember the quotient rule. There are many songs and poems that people have written of all types and varieties. The one that I've always used is this one right here that you see in quotes. To remember the quotient rule, low d high minus high d low, square the bottom and away you go. Please make sure that these words rhyme because it's a poem. If you don't rhyme those words, you might put your numerator in the wrong order. But low d high minus high d low, square the bottom and away you go. And in this particular poem, low refers to whatever's in the denominator. That's your g of x. And high refers to the numerator. Oops. High refers to your numerator of your original. And so there you see what we've got going on. You can see it going across low d high minus high d low, square the bottom, and away you go. And that is your quotient rule. Let's go ahead and do a couple of examples. We're not going to get through all of them, but let's start a couple of examples here, and then we'll call it quits. Maybe we'll do the first two examples, maybe three. We'll see how the time goes. All right, so the derivative of y equals x squared plus 4 over the sine of x. So we've got dy dx on the left-hand side, and over on the right-hand side, we're going to apply the quotient rule because we have a quotient. So it's going to be low times the derivative of high. The derivative of x squared plus 4 is 2x minus high. Please make sure you appropriately use parentheses around that multi-term quantity, times the derivative of low, and then we're going to square the bottom. And then we're going to basically just, kind of, clean up the numerator. And so we've got dy dx is equal to 2x sine of x minus, and I'm going to go ahead and multiply this out. I frequently multiply out the numerator of these problems just to see if anything happens nice for us from a cancellation standpoint. In this case, nothing does, but I never multiply out the denominator. And there's our derivative. All right. You know what? We're going to call it quits there because example B might take me a little bit of time. So we'll call it quits there. We'll come back for a second video, maybe even a third on this subject, depending on how our time goes. So hope to see you then, and enjoy the rest of your day. Have a good one.